Hi everyone, it's Wasta from Memgraph, and today we are going to explore the deaths on Game of Thrones TV show. I know that the bad taste from the last season still lingers on, but let's be honest, we enjoyed the ride. Although we are still waiting for those books. Come on, Martin, you're not a young man anymore. Being a fan of the show and the books as well, I'm particularly glad to take you on this exploration, but I have to give credit where credit is due. The dataset we'll be working on was completed by our very own Mario, and the queries were written by Katarina. So let's get started. Let's do the basics first. So I've downloaded our Docker image Memgraph platform, and I'm just going to open the port 3000 because I'm going to connect to Memgraph platform using Memgraph Lab in my browser. So I run this command. Now that Memgraph is running, I can switch to my browser. And I go to localhost 3000. And my Memgraph lab opens there. It says the connection, and I can click on connect now, and I'm automatically connected. So as you can see, we currently have 0 nodes and 0 relationships in our database. So let's head over to datasets. These are preloaded datasets available in the Memgraph lab. And you can see here the Game of Thrones deaths dataset that we will be using today. So you can just click load dataset and confirm, and this will load the nodes and relationships. Okay, the dataset has uploaded. Let's turn off this window, and as you can see now we have around 3,000 nodes and around 12,000 relationships. So what does this dataset actually consist of? Let's go and generate the graph schema of the dataset. So here we can see all the nodes and relationships we have in the dataset. So let's start with the character node. As you can see, all the characters killed each other. All the characters are loyal to some allegiance. Characters are either a killer in a certain death or they're a victim in a certain death. And all deaths happened in a certain location. All deaths happened in a certain episode of a certain season, so all deaths happened in a certain season. And this is what our dataset is about. So if we head over to the query execution, we will not return only nodes. Let's return all the nodes and relationships in our dataset. And let's run the query. So this is the whole graph with all the nodes and relationships. The rest of the queries I won't run here because I've created a query collection. So query collections are prepared queries you can run on your dataset, and they will lead us through the story of this dataset. So let's see the basics. Let's find out the number of seasons we have in Game of Thrones, the number of characters we have in this dataset, and the number of deaths. In Memgraph Lab, I could run all of these 3 queries and then pick and choose which results to see, but I can also select a certain query and then press run selected. So here you can see that the total number of season is 8. Then we can see that the total number of characters we have in this dataset is around 300. And if we find all the deaths, mousework Wasta, we can see there are around 2,000 deaths in the Game of Thrones, which is quite a lot for a TV show.
Aww.
Okay, so do you remember how many episodes each season had? If not, let's run a query. So what we're doing here is we are matching episodes that are a part of a certain season, and then we are returning the number of the season, and we are collecting all of the episodes in a list, and we want to order it by season number. So we have 1 till 8. So if I run this query, I will also see the episodes in a graph, or if I go to data results, I will see the number of the season and the episodes for each season. Here, if you know how many episodes there are in a season, this will probably look strange because this data is incorrect. Well, it's correct for our data set. So let's see how many episodes per season there actually are. So let's say Game of Thrones episodes per season. And the first result tell us that the first 6 seasons had 10 episodes, the 7th had 7, and the last had 6. So that's inconsistent with our results. Well, that's because we're only showing deaths here. And what we can conclude here is that in certain episodes, there were no deaths. When consulting certain fan wikis, we found out that they are listing 7 episodes with no deaths, but in this dataset, you can see there are only 4 episodes without any deaths. So let's find out what deaths the fans didn't count. So let's see who died in the first episode that we have a death recorded. So I'm going to run this query that is finding a character who was a victim in a certain death. That death happened in a certain episode. That number of the episode is 1. And that episode is part of season 3. And let's see who that character is. Can you guess it? So here I'm showing you that you can run both queries and then decide what results to look at. So it says here that we have 2 queries and currently we are looking results of query number 2, but because I don't have anything written here, it's just an empty set. So I'm gonna switch to results from number 1. And who died in season 3, episode 1? It's Manticore. Do you remember anything about Manticore? Who he is? What has he done? Let's find out something more about him. He was killed by Barristan Selmy. He is loyal to none. So who do you think that is? And this is him and the moment of his death or her death. We will never know. So let's move to the second death we have in our records. So it's from an episode number 2. It's part of the season number 3 as well. So if we run it, it's Hoster Tully. So do you remember how Hoster Tully died? Let's see. What do we know about him? So he was killed by none. That's strange. So how did he die? If we click on his relationship with his death, we can see that the method of being killed was illness. And lastly, let's see who died in episode number 2, but season 8. It's Ned Umber. So do you remember anything about Ned Umber? He actually died twice. So he died once in season number 8, episode 1, when he was killed by the Night King. And then he was killed again, like this. And I guess why the fanwiki didn't count the second death as a death is because he was already dead. But we have it in this dataset. Okay, let's move on to the second happy topic. It's suicides. Let's see which character was killed by the exact same characters. So if I run this query, I can see a number of characters who died, and the method of the death is quite interesting as well. We have various sharp objects, but also poison. Some very well-known names like Melisandre, the Red Woman, who died of old age. Aemon Targaryen also died of old age, which is, I guess, a very rare occurrence in the Game of Thrones world. But because Melisandre should have been dead a long time ago and only kept herself alive by magic, I guess the real winner of Game of Thrones is Aemon Targaryen. Okay, let's move on. We talked so much about that. Let's see how to stay alive. So, what part of Westeros should you avoid so you don't get killed? We are going to calculate this using PageRank. So we are going to find all the deaths that happened in a certain location and save those paths as a subgraph. Then we will call a PageRank on this subgraph, and we will get all the nodes with their ranks. PageRank is actually calculating the possibility to land on a certain node if you're going around the nodes in a random order, in a random path. So the values can be from 0 to 1. And with that node and the rank, we will only look at nodes with a location, and then we will return those nodes as where and their rank as the page rank, so the highest possibility. I'm gonna change this to descending because we are interested what places to avoid. So let me take this first query and run it. So what should you avoid? You should avoid King's Landing, of course, because a bunch of people died there. So the page rank of King's Landing is 0.24, and you should also avoid Rose Road and Winterfell and Marine and the Twins and Beyond the Wall. All seems like really logical places not to be. But let's see where you should move. So I guess the real estate is booming in Highgarden, Valeria, Lashard, the Vale. All sound like really lovely places to live. No deaths there. To confirm what the page rank was showing us is to actually see how many people died in those locations. So if we match all deaths that happened in a certain location and we return the locations and we count the deaths that happened there, we should get King's Landing again as the highest one, and here it is with 1,170 deaths. So avoid King's Landing. But the only issue here is that King's Landing was mostly safe, right? It's the capital city and it has very high walls. It should have been safe most of the time, right? It's not only the place to avoid, but it's a particular time. So let's see what's the worst time to be in King's Landing. We will do another PageRank algorithm. This time we are looking at deaths that happen in a certain episode, not a location. We are again saving this to a subgraph as a subgraph and then running a PageRank on that subgraph. And with all the nodes that we get from the algorithm and their rank, we are just going to filter out the episode nodes. And then we are going to return node names as a when and rank as a PageRank. And we will order that by PageRank, descending, and just look at the first 10 results. So let's run this query, and again we will find out to avoid King's Landing you shouldn't be at a time around Daenerys' attack on King's Landing, which actually makes perfect sense. This is season 8 episode 5 when Daenerys is attacking the King's Landing and just killing all the civilians and turning into a mad queen and not really caring about anyone's life. Again, to kind of check if the death count matches the page rank we got, let's just see all the deaths that happen in a certain episodes and return those episodes names as episodes, and then count all the deaths and see them as death count and order by death count descending, so from the highest, and also let's see the first 10 top results. And we are right, so the bells have around 840 kills happening. So avoid King's Landing in the last season. First couple of seasons, perfectly safe to live there. So let's move to a bit of a different topic. So let's hear who the winners of the Game of Thrones are. We know who ended up sitting on throne, but let's look at what house suffered the least casualties while doing the most damage, or let's check the kill-death ratio. So we are looking at characters who killed other characters which were loyal to a certain allegiance. And then we are counting those deaths. And also we need that allegiance in the next query, where we want to check how many people from that allegiance killed other characters. So we are looking at the allegiance, the sum of the kills, the sum of deaths, and we are rounding that to get a nice number. And we are ordering it descendingly and limiting results to 10. So let's run that query. It looks like White Walkers had the Beth kill to death ratio, which is not very hard to have if you can't really die. But good job, White Walkers. And now let's look at who suffered fewer losses at the Battle of Bastards. So the Battle of Bastards happened outside of the walls of Winterfell, and it was Jon Snow leading the Stark army and all the other clans against the Bolton family. And there were a lot of deaths there, and although the Starks won, they had a lot of losses. So let's look at how many losses there were and who actually came out victorious based on the death. So we're going to run this query, and as you can see, House Bolton lost 49 people and House Stark lost 42 people. They won, but they also lost a lot of good men. As this whole dataset is about killing, we are going to look at the most important node in the graph, the one responsible for most of the deaths, because that's the killer influencer. And we are going to do that by using Betweenness centrality. So we are going to call the Betweenness centrality on the whole graph. We are going to find the character who has the highest Betweenness centrality. Do you know who it is? Can you guess? It's Daenerys Targaryen, of course it is. Because she turned out to be the Mad Queen. Let's see just how many people she killed. So here we are looking at Dany, how many victims she killed, and then looking at all the deaths and in which episodes most of those deaths occurred. And then we are returning the victim name and the count of deaths. Why are we doing that? Is because not all victims have a unique name, so not all the victims of Daenerys are Cersei or Jaime Lannister. It's soldiers. We don't see them as unique people, unfortunately, because we don't know their names. We see them as just soldiers. So we are interested in how many soldiers she killed besides the unique names of characters. And in which episodes. Let's run the query, and you can see that she killed 374 Golden Company soldiers and King's Landing citizens and Lannister soldier. Here you can see in which episode, so the bells again kind of pop out as the episode where she killed the most people. She also killed Cersei and Jaime, and she's our killer influencer. So now let's talk a bit about Jon Snow. Do you remember who killed him? Let's check at the character Jon Snow, who was a victim in a certain death, and we are interested in the character who was a killer in that same death. We are also interested at who killed the person that killed the killer of Jon Snow. So do you remember who killed Jon Snow? It was Ollie. There was a whole plot how they're going to kill the commander. Ollie was the last to kind of get the last stab at Jon, and then later Jon sentenced him to death along with the other traitors. So when you look at the graph here, you get a circular graph because Ollie killed Jon Snow, and then Jon Snow killed Ollie. Jon Snow later resurrected, so here we are interested at who would stay alive if Jon Snow just stayed dead. Why couldn't you just stay dead? I'm joking. He's our favorite character, and ultimately he brought Daenerys down. A lot of soldiers, but again, Daenerys Targaryen, Ollie, Alistair Throne, a lot of Stark soldiers, and some other characters. When talking about treason, let's check who was the most treasonous person, or who actually killed the most people from the house they belong to. So we are looking at the character who killed certain victims, and both the killer and the victim belong to the same allegiance. So if you kill from your own house, you are the most traitorous person. And we are returning the killer name as the traitor, and we are counting the victims, and let's look what allegiance that is. And then we are ordering that by kill count and limiting results by 10. Can you guess it? It's Jon Snow again, because he was in the Night Watch, but he killed a lot of Night Watchers. And then the next one is Theon Greyjoy, who killed 4 persons from the Greyjoy family, and then it's Bolton, who killed 4 people from the Bolton family. And now let's see the Dijkstra algorithms. What we are interested is what is the shortest path of killings with the highest kill count. So how we are going to get that? We are going to look at the path of characters who killed someone, and we are going to find the shortest path with the weight. So the weight will be a property of an edge of a relationship called count, which is actually how many people were killed. And we're going to save that as kill count. So how many characters killed other characters, and we are finding the shortest path. So Ollie killed Jon Snow, Jon Snow killed Daenerys Targaryen, and Daenerys Targaryen killed 374 Golden Company soldiers. And the last query I will run is not because of some insights that we will find out, but because I want to show you how to change the graph style. So we are looking at all the characters and other characters or allegiances. So we are looking at all the killings and to what houses those characters belong to. And what I actually wanted to show you is how the style is different here. And you can also probably notice that this House Lannister has their golden lion here, and the House Stark has the direwolf. So you can do a lot of things to make your graphs visually appealing using the graph style editor. So here you can see the code that changes the appearance of the nodes and relationships in the graph. So here you can see that we are defining a new procedure because we want to see what nodes have the name of House Lannister. So let's make a new allegiance. It's going to be House Martell, and we are going to define its color. So if we Google House Martell, their sign is this speared sun, and it's in orange colors. So let's use some kind of orange. And the color I like is FFAE42. And here you can see that this is the image that will appear, and this will be the colors that are used. So we are just going to copy this from the Lannister family, Lannister house, and make it Martell. And we're going to use some image to replace this. Okay. And then we are going to change this to, so we're defining a style, just like all the other houses have. And okay, this is the Targaryen. And we are going to change the color of the edges. So is House Martell. We'll use the color of the House Martell. Here as well, these relationships are a bit thinner as we change the width to 0.5. And that's it. We did everything, and we're going to apply it. Oh. Okay. So let's apply it. And let's go to the full screen. And now you can see the House Martell here. It has the sun spear and all the connections between the House Martell and other characters are in this orange color. I'm going to do some more changes now and get back to you to show you what I did. Okay, so I'm back. What did I do? I went to the Game of Thrones wiki and I took the photos there to insert into my dataset so that each node that has name Daenerys Targaryen uses a picture of Daenerys. Each node that has, just one node that has the name Jon Snow uses the picture of Jon, Ollie uses the picture of Ollie, and Golden Company soldiers use the picture of Golden Company soldiers. So I can save this style, character images. You can do this for all the characters, and I can go back to my previous query and I can use it. And when I get my graph, I see the pictures, and it's much prettier this way. So there's a lot of things you can do with the graph style editor. You can change how and why your nodes change appearance, or how and why your relationships change appearance, the thickness, the size, everything. So be sure to check the GSS documentation. And that's it. If you continue exploring the dataset on your own and you find out some really cool stuff, give us a shout on our Discord server. And I'll see you around. Bye!